Hi students, I am Dr. Dhanamol, Professor in AI&DS. I am going to explain about file system implementation. Okay, we all know that we are going to save the file. The operating system plays a vital role in storing and retrieving the data. Okay, so file system is one of the area where the operating system has most of its jobs should be done within the stipulated time. For example, if you are storing the data and if you want to open the file, it should take the file from the secondary hard disk to the primary device. Okay, so that's what the file system is all about. How we are going to store and what are the structures available to store the data. That's what we are going to see in this video. The file system is an integral part of any operating system. Uh, okay, which provides a structured way of storing and accessing the files. Okay, the implementation of a file system involves designing and developing software components that manage the organization, allocation, and access to the files on disks. Okay, this includes maybe uh, managing the physical storage devices, and it also keeps track of files, attributes, and metadata. It also enforces security and access control policy on, and it provides utilities for managing files and directories. The file system implementation plays a crucial role in ensuring the reliability, performance, and security of an operating system, file storage capabilities, and it requires sophisticated software design and engineering techniques to achieve these goals. So based on this introduction, we are going to see uh, these things, that is file system structure, file system implementation, directory implementation. We are going to see the allocation methods and how the free spaces are managed in this category, and how it is very efficient, and the performance of the file system implementation is going to be seen in this. So file system structure. So we know what is a file. It's a logical storage unit where it contains the collection of related information. File system resides on secondary storage. We all know that. Okay, so whatever the things that you are doing, everything is going to be stored in the secondary devices. When you are want to access the files, it will taken from the secondary to the primary device. And it provides an user interface to storage, mapping local to physical memories. Okay, and it provides a efficient and convenient access to disk by allowing data to be stored, and it should be located, retrieved easily. And the disk in this provides in place rewrite and random access. So that is another important area where the file system is working on. And the input and output transfers performed in blocks of sectors. Okay, so we all know that what is a sector and what is a track and all, how the data are stored, everything we have seen in the previous classes. So based on that, we are going to see this. So we have a file control block which can control all the information about the file. Okay, so it's a storage structure which consists of information about the file. Okay, and we have a device driver that controls the physical device. Okay, and we are also having a file system which are organized in layers. Okay, so when we are talking about file system structure, we have a different layer file system. So one is the topmost layer is application program, and we have a logical file system, and we have a file organization module, and we have, that's what the allocation module is all about, and we have some directory structure at the beneath. Okay, so we have a basic file system, input output control, and we have a devices which are accessing the file. Okay, so what is file system layers? So these are that. So device drivers which can manage the input output devices at the input output control layers. Okay, for example, so if I want to retrieve a data, okay, so it will be stored in some drive, maybe C drive or D drive. So we are giving some commands like you have to read the particular drive, and you have to read the particular cylinder number and the track as well as sector, and also the memory location where it was stored. So everything should be taken care by the device manager. Once what you are doing is simply clicking, so everything will be taken care by the operating system. And we are coming to the basic file system, given a command like retrieve block 123. So that translates to device driver. So all these things are commands which was practiced inside the OS. It also manages memory buffers and caches. So that's what the allocation, freeing of memory, replacements, everything will be done in the memory management. Okay, and the buffer holds data in transit and caches hold frequently used data. Okay, so that's what if you are opening 3 or 4 files at a time. Okay, the file which is in access will be in the cache memory, whereas the other things will be residing in the primary memory and all. Okay, so and file organization module understands the files, logical address, and as well as the physical blocks. So it also translates the logical block to physical block, and it also manages free spaces and also disk allocation data. Okay, so we will see one by one. And logical file system is nothing but the file how it is stored inside the operating system. That is the logical address. Physical address, sorry, we have a logical name to every file that we are giving. Okay, so it translates the file name into file number and file handle location by maintaining a file control blocks. Okay, so we have a file control block in Unix. You can have a inodes. So this inode in Unix will take care of the translation, and we have a directory management, and it also take care of the protection of files. Okay, so it restricts the unauthorized user to access the particular file. So that's what the protection is all about. Layering useful for reducing complexity and redundancy. Okay, so why we are having this layering is it's mainly meant for to reduce the complexity and redundancy. But it adds overhead and can decrease performance, translates file name into file number, file handle, location by maintaining the file control blocks. And we have a logical layers which can be implemented by any coding method as per the requirement of OS design. Okay, so these are some of the file systems which is used in the operating system. So which has its own format. For example, if you take CD-ROM, the format will be ISO 9660. In Unix, we have a Unix file system. Okay, and Windows, we have a file allocation table, FAT. That's what we call it as FAT. FAT32, NTFS, network file systems, all those things are available. And we have a floppy drive, it is in some other format. We have a compact disk and we have a DVD Blu-ray, and we have at least minimum of 40 different types of extended file systems. Okay, so that's what everything we are having. Still, we are not talking about ZFS, Google FS, and Oracle ASM and FS. Okay, these are still not that much useful by the common man. Okay, so uh, we have a file system at API levels. Okay, so what is that file system? So the file system organizations refers to how files and directories are stored on the disk. Okay, if you take a file system which is more responsible for managing files and directories, and it provides a way for users and applications to access and modify them. So different file system may organize files and directories in different ways and may use different methods for storing and accessing them. That's what we have seen earlier. And when we are coming to the boot control block, which contains information needed by the system to boot OS from that volume. Okay, if needed volume contains OS, usually first block of volume. That's what we all know that an operating system is a system is switched on. Okay, so we have already seen the operating system itself loads onto the computer. Okay, actually it is on memory. From the secondary memory, it will be actually taken to the primary memory, and then it loads the other user-defined files as well as system files and all. Okay, so we have a volume control block which contains volume details like total number of blocks and number of free blocks, block size, free block pointers or arrays, everything. And directory structure organize the files in in the form of names and inode numbers and master file table. All those things are maintained. Okay. So and we have a FCB, that's what file control block that contains these details. Inode number, permission, size and date of the file, and NFTS stores in the master file table using relational database structure. So it contains the file permission, who can access the file, all those things, and file dates, file owner, group, and file size, file data blocks or pointers to the file blocks. All those things will be taken care. Once the file is opened, it will be mount table. We have a mount table storing the file system mounts. So we have a mount point, file system types. The following figure illustrates. Okay, so you just see this figure. So we have a file which has a user interface. So I have a kernel memory and I have a secondary storage. Okay, so if I want to, if a user wants to open a particular file, it will be taken to the kernel memory. So where I have a directory structure, from the kernel memory, it will be taken to the secondary storage device. There also we have a directory structure and also we have a FCB. Okay, so this is what happens in the case of first case. So in second case, to improve the performance of the file accessing, so we may have an index. So we have a read index. So whatever the things we have recently read, all those things are indexed and kept in the kernel memory. So that's what in the case of second thing. When we are coming to the directory implementation, okay, so we have a linear list of file names with pointer to the data blocks. Okay, how the data are stored in a linear linked list. The same way we are going to store the data in the case of directory implementation. So first I have to access the directory. From the directory, I have to access the respective files. Okay, so if we have subfolders and all, first we have to access the subfolder and then the file within the subfolder. All those things comes in a hierarchical way. So linear list of files pointers to the data blocks. It's a simple to program and it's a time consuming to execute. So we have different types of accessing the things, linear search time, but it can be easily tracked using V plus tree. Okay, so that is very much useful compared to the linked list. And we are also having hash table. Hope you might have studied in a data structure. So we have a hash table, so which is used to access the type table with using index. So it decreases the directory search time, but it has a condition that the same location we may get two different files. So that is the condition that occurs. In this case, only good if entries are fixed size or of chained overflow method. So if we have that type of method, that is very easy. And we have an allocation method. So we have a contiguous memory allocation method. Okay. So let me see this. So what is contiguous allocation method? So So in the contiguous memory allocation method, so we have a group of files. Okay, for example, we have a fixed size of blocks. If the size of the block is, if the size of the file is exceeding the block, then automatically another block of memory will be allocated to that. So that's what the contiguous memory allocation is all about. A group of memory will be taken together and store the file. Used to store the file. That's what the contiguous memory allocation is. And how you can access the file is the using this formula, that is how what block you are going to access, which block you are going to access, that will be taken as q plus starting address, and the displacement into the block is or how much distance it will go on. For example, if my file is stored from 14th block and it executes, it is stored up to 16th block, means that's what the total memory allocated to the particular file. So that's what we have in this case. So you just see the starting and length of the count. Okay, all those things. Okay, so my extent based system. So it's a mini linear file system. Is a modified contiguous memory scheme. So what we are calling it as extent based system. Okay, extents are allocated for file allocation. A file consists of one or more extents. So this is allocation method. We have a linked list allocation. So hope you have studied in a linked list in data structures. Okay, so each file, a linked list of blocks are there. File ends at nil pointer. No external fragmentation will be there. Each block must contain pointers to the next block. Okay, so you all studied all those things. No compaction, and there should not be any external fragmentation. A free space management system called when new block needed. Okay, so it improves the efficiency by clustering blocks into groups, but increase the internal fragmentation. Okay, and reliability can be the problem because we cannot say that okay always it is correct, and it also takes more time to access the data. Locating a block can take many input outputs and disks. So this is one type of allocation method, FAT, file allocation table, which is used in Microsoft Windows. Okay, so we have a FAT32 and nowadays we have FAT64, all those models are there. So it's the beginning of the volume has label indexed by block number, much like a linked list but faster on disk and catchable. Okay, so this is a linked allocation. So I have a block and I have a pointer. So you all know that pointer points the address of the next node. Okay, so when you are coming to the doubly linked list, it also points to the previous node. So that's what we have in the file allocation using linked list format. So this is an example of linked allocation. So instead of continuous memory allocation, I can go for storing the data wherever I find different location, memory location. So that's what we have. And this is the file allocation thing. So when I'm allocating, so I will find the free blocks in the whole memory. So in the free blocks, I'm going to allocate my table. So this is the index for each allocation. So in the same location, one or three files may be allocated. So this is what the index is all about. So it is easier to access the file. So if you have index, you can easily access the files. So we have a need index table. So what we need, we have a random access and we have a dynamic access without external fragmentation, but have overhead of index blocks. Okay, so this is what we have. And we have to map it using the block of index table and R1. So this is a two-level indexing. So we are going to have an index for index. Okay, so that's what the two level of index is all about. So this is what we have, outer index, inner index. So this is a free space management. File system maintains a free space list to track available blocks clusters. And we have a bit vector or a bitmap n blocks. So bit of I, 1 is equal to block file of I and 0 means it is occupied. So how I can identify the number of bytes it occupies is based on the formula number of bits per word into number of zero value words plus offset of first bit. So all those things comprises of identifying the blocks. So bitmap requires extra space. Like so when I want to store the bitmap, so it needs more memory space. So I have to allocate a cluster of blocks will be allocated for that. So easy to get contiguous files. So this is a free space list in the case of list. So we have space maps are used in ZFS because we are not going to use ZFS in our day-to-day life. So Google and all they are using ZFS. So the efficiency and performance. So efficiency is completely depends on disk allocation and the directory algorithms. And we have a types of data kept in the files directory entry. So what type of data that also used to identify. For example, if you are storing a text data, it will be retired very fast. But if you are storing a image files or video files, then it will automatically take more time. And a pre-allocation or as needed allocation of metadata structures. Okay, so that is also the fixed size or varying size data structures are used. So when we are coming to the performance, so keeping data and metadata close together. So we have a buffer cache, we have a synchronous, asynchronous, free behind and read ahead. Okay, so all those things are common in the case of indexing file structure. Thank you.